Welcome to another Baka commentary video. In this video will be me giving my opinion and analysis of right now what happened with the Intel failure. And apparently even AMD had a few problems, and I might as well as bundle both of them in one video. And yeah, let's first talk about the more prominent issue, the Intel 13th and 14th gen failure. And let me give you first some quick timeline about it and then give you some more detail for the people that want more detail. So, at first, we thought it was just the i7 and the i9K chip which had the problem. And then Intel saw that and be like, hey, okay, let's do a BIOS microcode update and enforce stricter Intel spec out of box. Unfortunately, this didn't work, and as a result, other people then start that updated it has also then started coming out and be like, hey, we never overclocked the chip or we were on the latest BIOS and we are still crashing even if we stuck to the Intel spec. This means, again, it's no longer the gaming Ks and the non-K pre-built that are having problem. Even data center guys were like, yeah, Intel 13, 14 gen, we are having problem too. And then after that, what made this really damning for Intel is you had game developers coming out, and for the really ballsy game developers, like Digital Explain, they publicly published their crash data they got from user and internally, all pointing to be like, hey, yeah, our which enforced the 13th and 14th gen K chip were indeed had failure problems. They didn't indicate enough of the lock chips. Maybe it didn't have enough time and maybe it lasted. However, lastly, Buildzoid then did a 1 hour rambling on his speculation and his experience with Intel 13th and 14th gen as an extreme overclocker, and he speculated on like what's the potentially the problem and what he actually ran into while doing extreme overclocking, which enforced the degradation theory that a lot of people were carrying around. Now, time to give you guys more detail of more information about this Intel 13 14th gen failure. So, the known issue with 13 and 14th gen is Intel Performance Core can degrade to a level where undervolting and underclocking can no longer stabilize it, and outright that P cores need to be disabled in order for the CPU to run per normal. Intel spec or overclocked, whatever. The next thing that is found, the Intel ring bus connection can degrade. This has resulted in needing to disable cores that are affected that in that ring bus. So like if that part of like the P core, that one of that ring bus that's going to it, every core after that ring bus needs to be disabled. And sometimes what is very prominent with the ring bus is the E core ring bus connection is failing connection to the P core. So a lot of people are now disabling E cores to get stable Intel 13th and 14th gen POM. And a next issue is, well, power level and as well as voltage. In order for Intel to guarantee all their i9s and i7 to reach these really, really high clock speed, Intel has made a really, really ambitious power level to ensure that all CPU, however, not all the CPU, the good CPU, they can use lower power, But guess what? Majority of the motherboard vendors, they disregarded that Intel reference, and even after the BIOS update, and be like, hey, yeah, we're going to use the highest power level and the highest voltage curve to ensure our customers get the really high clock speed. But this has resulted in dangerous voltage and dangerous TDP level given to injected into the CPU, and result we have a lot of Intel 13th and 14th gen failure. As well, which then next to the next problem with the BIOS update, what else have they done after the BIOS microcode has failed? Microsoft, they tried to enforce each different power levels to have different clock speed and voltages. And again, some motherboard vendors did do that. Some motherboard vendors, again, just like previous microcode, they just never cared and they just went highest, and again, same issue pursued. 13, 14 gen were dying because, again, there was too much power being pushed through, too high TDP being pushed through, or some pre-built simply did not have enough cooling to sustain the higher power level which those motherboards were driving to the CPU. However, during these microcode update pushing, this has also affected the data centers, the workstation guys, who never overclocks their board and uses standard JADEX RAM. Those guys, they were really annoyed when they were having i9s, or their CPUs unstable. They never overclocked them, and they never used even XMP RAM kit, and all they used was ECC JADEX standard RAM. And when those things before and after microcodes updates, they were then still crashing, and they found that like degrading, be like those guys, and due to even on the low voltage, hence their low TDP variant of the desktop chip ended up like, hey Intel, this is no longer just your high performance power level POM. Your low power level, your out of box sometimes is undervolting to a point where it is not stable. And in a lot of data centers, they are not willing, or they can't, up the voltage themselves. As one, it's probably against their terms of service as a technician to do these things, and they are to stick by this JADEX and whatever Intel reference center they get from like Dell, HP servers, and they cannot touch that. And again, now on to the more rumor mill stuff, which is according to Tom from Moore's Law, Intel does have a plan to reimburse the business/workstation users as well. They're basically going to go reimburse the user, those data center and the server guys, be like, okay, we'll send you a replacement chip. We know Intel 12th gen. We'll give you an Intel 12th gen equivalent, or we are going to give you an Intel Core Ultra chip that will fit into that LGA socket. And oh yeah, thank you for putting up with us, Pom. Hopefully this stops you from complaining and suing us and canceling our contract. And yeah, that is basically all the detail I could get out of this Intel 13 and 14 gen failure issue. And now let me move on to the AMD issue, which seemed to get less coverage by the mainstream tech media and most tech YouTubers. AMD Ryzen 3000 series seemed to have some degradation issue, and a lot of time, so for some of the 3000 users, their CPU has failed outside the warranty period. But for some lucky individual, they were very lucky to have their CPU fail within the 3 years of the AMD CPU warranty period, and AMD were like being very gracious and just replaced that chip. And basically, in in my opinion, is this okay? No, AMD, this is not okay. You're lucky that you guys have a 3 year warranty, as well as, for people unaware, AMD also has CPUs, unlike their competitors, as time goes on and ages, and AMD CPU tend to drop in value, new and used, so a lot of time some users who are willing to be like, yeah, I'm okay with buying a cheap replacement CPU, those guys tend to be okay with it. So, like, a lot of the AMD custom Ryzen customers that had the chip fail, they were not very pissed, and very, very small more amount of people that were pissed. I think the only ones that were really pissed about this AMD Ryzen 3000 degrading palm blowing up issue was really just retailers, because they had to, you know, spend time RMA of like warrantying customer chip, and basically their profit margin for these CPUs were gone. So like, corporate was the one that complained about it. The end user wasn't really complaining about it. The next AMD Ryzen problem they had was AMD threadrippers. Some of them, they developed issue with scheduling, or in some cases weird leaky behavior where it was very, very hot. But however, I wasn't able to really get a lot of information about it. However, one thing that I can really think is AMD Threadripper, unfortunately, is a product where the operating system and the software wasn't really ready for them when they launched. So a lot of time, a lot of these Threadripper CPUs, they ended up having to like disable hyperthreading or even cores to ensure that there was no weird issue with those things, as for some programs they were just not ready for this AMD Threadripper core and how much cores and threads would get that those platforms enable the users to have access to. As well as, for them give you more context, AMD Threadrippers and the AMD Data Center Epic CPUs were basically the same CPU. It just that happened that Threadrippers CPUs, yes, they're high-end CPU for you consumers, but to AMD, these CPU are failed validated data center CPU that didn't make it the cut for the data center spec, and just went, they potentially have leaky silicon, not great voltage curve. Those end up being sold as AMD Ryzen Threadrippers. And yeah, so you're looking at already bottom barrel yields of them. Are they better? Basically, AMD Ryzen, you're getting consumer grade, and just getting crap ton of cores and PCIe, getting a hybrid. So, and also for those don't know, AMD and the data center chip, they were in very, very huge demand, and really AMD had no reason to really give good, reasonable yields to Threadrippers, which were generally what happened with the Ryzen 1000, 2000, and even that you got. Those things, why did they never end up with any of leakage issue? Probably because the data center's demand for those chip wasn't high enough, so that they ended up just giving you some of the data center chips for the Ryzen 1000 and 2000 chip and the 3000 and 5000 Threadrippers. The data center were like, no, we needed these damn CPUs to be data center chip. It's higher margin for AMD to sell them, and the lower margin and Threadripper stuff, yeah, we just give you the most bottom barrel, bare minimum spec machine. That leakiness, yeah, you're bound to get. See, AMD threadrippers with really leaky silicon. Guess what? If they were already leaky from the factory, it's only going to get worse as time moves on. Yeah, this is AMD threadripper issue. This is an unfortunate thing with one, software and hard software wasn't ready, and two, you were getting the market condition didn't really in where the demand was in the higher margin product, and you just ended up being the kid that was left out in the street in the cold, forgotten about. That was basically the unfortunate left out kid. And that's basically it with me and my analysis on this AMD Ryzen issue. And yeah, I do hope you enjoyed this video of me basically giving my opinion / analysis on this Intel 13th and 14th gen failure issue, as well as the going under the radar AMD Ryzen issue. If you like the video and want to see more videos from this channel like this, click the like and subscribe button. And if you want to do the extra mile, share, and I'll see you guys in the next video.